This week's example is a nice one, just using your knowledge of adding and subtracting vectors and also magnitudes of vectors. So the first thing I'm going to do is just write down the vectors again. So I'm going to use the little tilde underneath the A to show that it's a vector, and I'm using the little hats on the I, J and K to show that they're unit vectors, so length of 1 in those three perpendicular directions. So the vector B, again, it has a little tilde underneath because it's a vector. Oops. And C also has a little tilde underneath because it's a vector. So they're the three vectors that we have. You can see here B doesn't have a J component because if you can imagine, it's just going across and up. It's not going across in the X direction and up. It's not going across in the Y direction. So the first question here is A. It tells us for A plus B, we need to find that vector. So all I'm going to do is simply add A, which is this vector here, and then add B to that. I'm just going to use a bracket around it. It's just good practice to use brackets when you're adding and subtracting vectors. With adding it won't matter, but with subtracting it will, because you'll have to remember that you need to negate everything that's inside the bracket. And here we're just combining the parts that are the same. So the i's, you can see you've got I plus 3i, so that would be 4i. You can see you've got a j there. You don't have a j in the other part, so that would be plus 2j. And then k's, you've got a minus k and you've got a minus 2k. So that would be minus 3k. So that would be A plus B. So 4i plus 2j minus 3k. The next one, B, similar kind of vibe here. You've got A, take away 2b. Write down A. So A is I plus 2j minus k. And this time we have to take away 2 lots of B, and B is 3i minus 2k. So this is where the brackets really are useful. I'm just writing out A again because we're not doing anything with that. Here we'll be expanding across the bracket, and you'll be expanding the sign and the 2 across both things here. So we're going to have, I'll leave this blue so you can see, this will be negative 6i, and this will be positive 2 times 2, which is 4k. So that's the expansion part. So again, we just look at what's the same. The i's, we've got 1 minus 6, so that will be negative 5i. The j's, we've actually got no j's here, so this will still be 2j. And the k's, we've got a negative k plus a 4k, so that will be 3k. So A minus 2b is negative 5i plus 2j plus 3k. C, same thing again, and you could stop the video here and make sure that you can do that yourself. Oops. So there's A, and actually I should really write down what we're finding before we do it. A plus B plus C. This is going to be kind of a long one, so I'll do it on the next part. 2j minus k plus B. Now I know that because I'm plussing, I don't really need to worry about the signs because they'll just be the same as they are. 2i plus j plus k. And here, because I've got so many things to work with, I am going to actually circle everything so I make sure I don't miss anything. I plus 3 plus 2, so that's 5, 6i. Done with those. The j's, I've got 3j. Cross them out when I'm done. And the k's, I've got a negative k, negative 2k, so that's negative 3k, plus k, so that's negative 2k. So that would be my vector, 6i plus 3j minus 2k. The last one is D, finding the magnitude of the vector A, and we just pretty much have to remember how to find magnitude. It's the parts in front of I, J and K that we square. So what's in front of I is a 1, we square that. What's in front of the J is a 2, we square that. And what's in front of the K is a negative 1. So we'll square that as well. So we've got the square root of 1 plus 4 plus 1, which is the square root of 6, which is the square root of, well, there's not really anything you can do with that actually, because it will be 2 times 3. So square root of 6 is as far as we can go there for the magnitude of A. So adding and subtracting, just being careful with your signs, and for the magnitude, just remembering your formula. Part in front of I squared, the part in front of J squared, the part in front of K squared, and the square root of all those things added together.